Good afternoon, everybody. I am Loren Long with SLEdge Consulting in London, despite how I sound. And I'm gonna let the panelists introduce themselves, but I'd like to start. There's been several discussions today about the great things we're doing in the data center industry around climate change and becoming climate neutral, net zero, et cetera. Let me give you a couple of numbers. So, these are U.S. numbers, but they're indicative, so we're going to use it. So, the total data center utilization in 2022 was 17 gigawatts. It is expected to go to 35 by 2030. The IPCC has called for a 48% reduction in emissions by 2030, not to bust the 1.5 degrees Celsius barrier. If we improve ourselves by 20% over the next 6 years, well, 7 years, that means that we're only over by 390%. And if that is any indication of global power utilization, we're done. And all that to say is that we need to have massive wholesale changes in how we approach what we do. And that's going to lead into, I think, immersion cooling is one of those. We need other ideas, but the status quo and incremental improvements isn't going to get us where we need to go. And I think that's seen in a lot of the public pressure that's coming our way. So with that, I'll start on the left side. If you guys please introduce yourself and your companies, and then after that, we'll get into the questions.
Okay. Left?
Please, left.
That's left. My name is Edgar van Essen. I'm managing director of a Dutch company, and actually I don't pride myself on being an engineer nor having 20 years of experience in the sector. Actually, before this I was in the telco sector, and I've been instrumental and also board member in setting up fiber to the home in Europe. And I see a lot of things that are a little bit comparable to this industry where we're now. It's still in an engineering stage. We're engineers talking to engineers, while I think we actually have a much broader topic that we should address on a larger scale. And that's what I might be doing during the panel discussion. My company is SLEdge Datacenters in Amsterdam, currently 200 megawatt under development. We have 40 megawatts live right now. We deal with enterprise customers, hyperscalers, and more do big chunks of megawatts, all sustainable.
Peterson, Senior Vice President of Product at CoolIT Systems. Our company specializes in direct liquid cooling and rear doors, so I'll be answering questions from that perspective today and not less so from immersion. But what I'm really excited about is offering some of the insights we get. We work all the way up front with the chip manufacturers, seeing generations out. We work with the server OEMs, we work with the hyperscalers, we work with the data center end users to deliver liquid cooling. And we see what's coming, and it's quite spectacular, I think, the shift that's about to happen.
Hello, everyone. My name is Bjornsgaard. I'm the chief executive of a business called Deep Green. We are building edge data centers. So you may have seen some press around us a couple of months ago when we were heating a swimming pool in Exmouth with a small data center. And we're now scaling up into district heating systems and other swimming pools and using immersion and direct-to-chip cooling.
I'm Luke Davies. I'm the managing director for GlobalConnect data centers. We have 17 data centers and a bunch of smaller POPs and repeater sites across the Nordics. Why am I here? It's because we installed one of these immersive cooling units in our main Copenhagen data center, and we're in the process of putting a unit into one of our Stockholm data centers, and I suppose I have some stories to tell about that process.
Immersion 4, Serge Conesa. I'm the founder and CEO of the company. We have been looking at immersive cooling since 2012, did from the carbon molecules of the liquid to the system itself. Having one of the first immersive cooling system can be serviced like an air-cooled rack. And we're basically doing full immersion, connectivity included, the fiber, data cables, electricity in a non-conductive liquid, guaranteed 25 years. We're not selling our solution, we are renting it. Basically, we take full ownership, and you like it, you keep it, you don't like it, we take it back. And the product is having multiple life. That's the way we do. In order to avoid the problems of, let's say, appliance manufacturer, what we are doing is we are guaranteeing with our solution every single modification we do and any damage we can cause directly and indirectly. So basically, no matter kind of a cloud provider you are, public, hybrid, or private, no, public, private, or hybrid, okay? We are basically have a solution, and we can rent our system by 10 new unit, or basically have a full scale from megawatts to hyperscale data centers on the 2.7 meters high building. For us, any building is a data center. That's what immersion 4 is all about.
Thank you. Okay, by a show of hands, how many people, well, are familiar with immersion cooling of any flavor? Most? Sure. Anything that involves, okay. Now, how many people have deployed it and have it operational? All right, pretty cool. Yeah, I would expect you guys. I mean, okay, so everyone's fairly familiar, but you know, for Serge and Brandon, if you could just very briefly, what are the different flavors so we can at least vote? Let's get that out of the way so we can all agree on what is, what isn't, and how it's done. Brandon, you want to go first?
Sure. Category-wise, we look at liquid cooling as direct and indirect. So indirect is when you're getting water closer to the racks. You'll have a rear door. You'll have an in-row cooler. Direct, we'd split into immersion and cold plates. And within both immersion and cold plates, you'll have what we call single phase and two phase. The main difference there being single phase is a liquid that stays a liquid to take the heat away. Two phase means that it actually turns from a liquid to a gas. There's a phase change happening. You'll find that covers pretty much every liquid cooling technology in the market. Very much an oversimplification, but should get you the right groupings there. And Serge, do you agree? Anything to add to that?
I agree. In fact, there is at least 20 fashion over, I will say, the liquid cool, from the liquid to the chip, liquid to the cassette, liquid to the rack. I said immersive cooling in cluster, immersive cooling in tanks, immersive cooling in DTM system, full immersive cooling, half immersive cooling, and so on and so forth. So we are basically a market where we are looking at itself because we have to deal with the legacy. So there is no good and bad options. This is all good for a simple reason. We are using a liquid as a thermal conductor, which is the paradigm shift. And we need to stop having these air cooling infrastructures.
Okay. So going from the it's all good to the now let's put it into operation. And now I'm going to ask the data center guys, the operators. Where have you seen currently and or in the past, as opposed to in the future, what are the best applications of anything liquid cooling related, immersion or otherwise? And also, where is it not? Because I have some experience trying to do it and it wasn't such a good thing. So,
Yep.
Go ahead.
Let me kick off. Actually, I think AI, HPC, they are very well, of course, those are the typical applications that will be the first ones to do liquid cooling. That's why actually the timing is good now with ChatGPT, GPT-4, GPT-5 coming in. The growth of AI will be definitely there, so therefore there will be much more liquid in data centers, for sure. If you look at immersion, I still personally see a lot happening in bit mining, which is a special industry. Everything, the customers that I serve have some more moves, adds and change to do in their racks, and generally are not so happy of pulling them out of an oil tank. So it's a little bit depending on what to use and how many changes they have. So the standard customers actually looking for liquid cooling are, in my perspective, much more the AI type and HPC type of customers than the Bitcoiners that we don't want to have in our data center.
Yeah, we've started with AI. So the Exmouth installation is a load of A100 cards. For us, it's less about the what's in the tubs, but more what immersion cooling can then let you do, because we're very anchored on that, on heat reuse. And I think that what immersion gives us is that structured heat. it's much easier to do something useful and interesting with the heat once it's immersed. So yeah, certainly AI, but actually the reality is that a lot of hardware and the rest of the panel can talk about it. A lot of hardware providers will immerse everything now. So we're immersing pretty much every large hyperscaler's kit that their specs we can just dump straight into a tank. So the actual barrier to this seems to be certainly lessening, I would say.
Yeah, I'm excited about the AI application, but in the near term, it's going to be less dramatic. And the first customer that was in there was us. We had to prove to our customers that we were willing to take this counterintuitive plunge of putting electronics into liquid to sort of pass the idiot test. And so we just took a normal server and switched off the fans and stuck it in there, and it works. Ta-da. But the two concrete customers that we're working with the most at the moment is in Copenhagen. We have a customer that's doing AutoCAD renderings. So for those of you that know what this is, it's basically rendering deeply detailed technical drawings into lifelike images used in advertising. It's very workload intensive, and so they're a perfect fit for this. And then in Stockholm, we have a customer that actually already has a lot of kind of traditional air-cooled infrastructure with us. And what they do is they create, very detailed CGI for the movie industry and for TV series, much of which you will probably have watched. It's very impressive. And they're really interested in this, primarily because it's going to reduce footprint, of course, carbon footprint, but primarily because of the cost. It's going to reduce their power bills. And I think if I look further into the pipeline, there is this common thread, which is people who are working with an awful lot of complex data, running their servers very hot, and they're very excited about the energy savings.
Okay, so we're gonna stay there for just a second, because my experience, and this was, well, it was a two-phase system, but I don't know that necessarily matters, but the economic model, or really the commercial model, from who owns the data center, who owns the tank, and then who owns the server. And in my experience, if you own all three, it works great. You start breaking it up, and the model gets a little dicey. Has that been your experience, or have things changed such that, no, you can just own the tank and the colo, and somebody else owns the server?
For me, it's a very simple position. I'm owned by an infrastructure fund. They have no interest in owning servers because they're like consumer electronics. So I'm going to have to make a pretty hard case to start doing bare metal or anything like that. So at the moment, I own the bath, and all of the infrastructure around that, and I invite my customers to come and stick their kit into that bath. Let's see how it works in the future. Maybe I'll have to change the model, but for now, that's what I'm going to try and stick with.
Okay. Interestingly, we're different. So we assumed that it would be a problem, that whole sort of ecosystem would be a problem. So we assumed that we will need to own a lot of the kit in our tanks. So we've gone out and raised, or are in the process of raising, a shit ton of money to make sure that we can offer that service bare metal at a decent cost of capital to take out the problem of that issue. But actually, as it stands, more and more people, 3 years ago, we couldn't get arrested doing it, and now actually people will tolerate. Some customers are coming to us and saying, they will put their stuff, they will. So we saw a brief recently for a large number of megawatts, and we asked whether they would do it direct to ship, and they said yes. So maybe the world is changing. I don't know.
Okay. Well, let's hear from the two guys that are selling it. What are, and not only from a commercial model, but what are the other impediments to adoption that you're seeing in the market?
Yeah, so I think in the previous panel there was some discussion about like hyperscalers. I think was it Rob? I think you talked about that, and I think what we've seen is that when you don't have to go to a new technology, a lot of these companies will choose not to. So I think necessity breeds innovation, and with the big increase in generative AI. If you talked to me like even 6 months ago, I would have said even within some of these other groups, the hyperscalers, it's going to take some time. I'd say that shifted with big shift and like scary numbers. There's an article in Forbes that suggested by 2030 there'd be a 200 times increase in power for generative AI applications in data centers, which is just an incredible number. And that will require liquid cooling. So we've seen conversations that used to be like, hey, how do we get ready for this? There's another question in the previous panel, like when do you need to be ready for it? I'd say now. If you're not preparing now, it's going to be a bit of a challenge to deploy those types of systems.
Can I say
Yeah.
something? That's from a technology perspective absolutely true. I think there's another element that we tend to forget in this whole discussion. That's a political element in Europe, in sentiment. I think if you're burning that amount of fossil fuel in Europe right now to start powering AI, you have the obligation to do something with that heat that you actually produce. And that's becoming, I think, a main driver of data centers like us to start changing the business model. Instead of becoming a data center provider, actually we become a heat producer and want to do something valuable with that heat. And we use it actually as a trading mechanism to get ourselves permits in the right spots. So it's much more than technology alone. It's a whole new business concept that we see taking off thanks to liquid cooling.
Well, in immersion 4, the way we are looking at electronics is, let's go back to the fundamentals. So when we have a server, it doesn't matter making a server running at 20C, 30, 40C, 60C, is what is the best use of the server at the right temperature, where basically we will be an equilibrium between the energy spent and the rendering and the efficiency of the server itself. So this is a very basic principle existing since the beginning of time called exergy, our house. Every single industry is based on this one. For sure, like you said, it is an issue when you use a liquid versus when you use air cooling. And what kind of liquid are we using? For example, two-phase liquid doesn't allow you to do the servicing. You need to service the entire tank or the entire pod, which on a single phase, you don't have that issues. But then after that, because you're using liquid, there is a problem of how the containment system is being done. What kind of joint are you using? How the liquid is circulating? How the temperature can circulate and being completely level no matter what it is. And those are issues that have to be taken care into consideration when you're talking about thermal liquid fluid exchange, true liquid to liquid horizontal exchange. What we do as Immersion 4, we look at the global solution. You guys are doing you're doing air cool. You know how to service an air cool rack. Everybody knows that since the beginning of time. So do I. I was part of the problem since 42 years when we did before Ethernet was even there. What matters today is to be able to service an immersed cool rack, cool tub, cool whatever, like an air cool rack, and to be able to provide the same service without using the entire infrastructure which is needed, talking about raise flow, high ceiling, chemical fire suppressor, HVAC, AC, and the hash rate normalization on the top of that. I'm sorry if I'm speaking fast. I'm just trying to take on my 2 minutes. And for this, what we are doing is we created basically not only the system, but we are leasing the system and we're providing the whole financing because for us, a data center is a real estate play. It's 4 walls and a roof. I know it sounds crazy, especially it's quite arrogant to say that in front of such audience, but at the end of the day, this is what it is. If we do immersive cooling, you basically don't care about the temperature inside the room and in which climate you are. You're basically solving problems like sovereignty and almost all the others. On a technical standpoint, how can we avoid you guys taking the burner or the server doesn't work, there is no guarantee, is immersed? Well, that's the reason why we are we are renting our system. And on the same time, okay, we're covering that with a global worldwide insurance for any damage we can cause directly and indirectly. For the time being, this is where we stand. I hope the market will change very fast, and then we will be appliances and electronics able to be immersed natively, because there's a big elephant in the room. It is e-waste. You must know that 1 container out of 3 leaving Europe, it's about to be recycled in Africa. 30 million women and kids are working on this.
Okay, you're totally blowing my next panel.
And I'm sorry. Should I finish my sentence?
Well, you got to come to the next
Okay.
panel.
The question is if you remove all the conventional coating on the top and the brominated, which is the highest, most toxic layers on the servers, you're making electronic recyclable. Immersive cooling allows you to do that. You solve e-waste by using immersive cooling. We're talking all sustainability, energy consumption. Don't forget all the aspects. It's a complete circular approach. We are all responsible for that, me first.
Thank you, Serge. But question, you're only preaching immersion. I don't hear DLC, which is the other flavor. Can you elaborate on that, maybe?
Absolutely. Well, can I?
Okay, be quick though. We got
Okay, very fast. So
got 14 more questions.
DLC, I would say, is liquid to the chip. It's something which has been existing for many, many years, which are being overperformed right now. The thing is that it's bringing complexity to the systems because basically you have, I would say, different, I would say, how you can say, enclosures on the top where the spots are. If you're looking the way I would say the PCB has been done, this is not only about CPU, GPUs. They're talking about FPGA, ASIC, memories, hard drive, we're getting heat sensitive. And it is not only about the heat, but I would say the way the system is completely designed, what is the best solution? Liquid to the chip, liquid to the cassette, liquid to the rack. There's many, many fashions to be there. I wish it would be a standard. One can say, well, this is a PCB, all the hotspots are displaced, and then removing complexity, because how we use all those materials. And if we use DLC, and I'm nothing against DLC because I think it's a great approach, it's a perfect fit for onboard equipment or for anything where this is moving, because moving a tub with liquid on a moving environment, this is impossible to do so. But what is very interesting to see is never forget number of chemicals used on the top of the PCB. We are now building and selling servers as crazy. What's happening to the server when they are at the end of life?
Okay, so let's change. And by the way, you brought up one elephant in the room. I've got another one here in a second. But so having deployed a tank in one of my existing data centers, and it was not easy. Number one, the floor wasn't right. I had several customers that didn't want a bathtub in with all their air-cooled equipment. So what kind of things, both from, from the operators and the vendors, if you've got an existing data center in the audience, what types of things do they need to consider when thinking about deploying?
Okay, if it's an immersion for data center, 1.2 ton floor loading, including the IT load, empty 800 kilo per square meters. If the floor is not leveled, you can basically, I would say, adjust the system in order to be sure to make it level, which is the first things you do when you install an immersion for system. Then after that inside, data and electricity are totally separated like an air-cooled rack.
Maybe another voice. You're preaching immersion, it's very clear. We had 10 years ago already the first tank in our data center, just like you. We experimented and we actually told the whole market to all our enterprise customers, including banks, enterprise or insurance companies, let's experiment in our top. It never happened. The reason is actually we have the CIOs of the enterprise companies are actually petrol heads in a certain way. They stick to what they know, and what they know is a server that is still running on a fan. And the fan is actually for them a natural element of a computer or a server, and therefore they don't want to change the thing. Just like their next car will be a diesel car and not an electric car. So what we need is actually start teaching the CIOs of this world and the purchase of hardware that there's nothing wrong with liquid and getting the fan out. And actually, I'm even preaching a little bit jokingly that we should try to get a fan tax in the computers. Actually, is the root case of why, and the root cause of why we're still not using liquid in a larger scale. So if we can phase out the fan, actually either by European law or by another way, we actually could create a much more a better momentum for liquid cooling, which makes sense for everybody, because then we can reuse the heat in a smarter way and don't waste a lot of fossil fuel.
Luke,
if you allow me to say just one thing.
well, let me let Luke. Did you have any lessons learned from your experience in deploying?
Yeah, I mean, the floor loading was one thing. Actually, our floors, they were over-engineered to start with, so we didn't need to, but then we reinforced them anyway. But the thing that we did do, and here I'm going to speak very briefly because I'm not the technical one. My technical director, my ops director, was sitting somewhere in the room, and I don't want him to shoot daggers at me with his eyes. But we basically built additional redundancy into the unit because when we got the unit from OEM, it didn't have the level of redundancy along the full kind of technical value chain that we needed. So we had to kind of consult with them to have some additional kind of relays put in. And again, because I was not involved in that personally, that struck me as quite easy and solvable. You know, probably for them it was not so much, but kind of knowable problem, right? I think the technical problems are not the real problems. The problems are the ones of adoption that, you know, Edgar is talking about there. How do you convince a bunch of people not used to this paradigm shift, who don't really need to do it, right? They're not regulated to do it. How do you convince them to do that?
But that's the Fantex.
Yeah, well,
Precisely.
Not yet.
I'll offer another perspective. I actually think that there's going to be a lot of folks forced into it. If you want to run the latest systems that are coming out later this year and the years to come, there just won't be a choice. They will be liquid cooled from the factory. It's not even going to be an option anymore in a lot of cases.
I think though the problem is that, you know, in our industry, there's some cool stuff at the fringe which is sexy and is coming in the future. But I personally have an enormous installed base of unsexy stuff, you know, legacy stuff that has no incentive or need to adopt this technology. How do you actually convert that? You know, can you ever? I don't have a clear answer.
Yeah. Serge, go ahead.
Well, I just wanted to say, I was said on the regulatory standpoint, sorry about that. Switzerland just passed a law by 2030, building will have to have zero CO2, no greenhouse emission. Data centers are going to be concerned. That's one on the regulation side. On the other side, I'm going to be on the beginning of July with the ITU, AI for Good, 185 nations are representing over there. And we're basically going to be, making a big footprint on, well, it's time to move to immersive cooling. Come on, guys. Ireland, for example, 15% of the energy of the nations is burned by data centers. And I'm not going to go there, even, that's another story. What is important, and like we said, there is many fashion, and like you justly said, the electronics component manufacturer today, okay, what you have for today is not going to be good for tomorrow. Liquid is going to be mandatory. And by the way, it makes sense. Thermal conductor versus an insulator. On the other way around, regulation have to change. The legacy of the product is very important. So there is two ways for the legacy. Either for the legacy that you can immerse, or either you wait the time that this legacy is being phased out, and otherwise the legacy that you can, which is worth to be modified in order to be immersed. Because the investment is already there. Why do you want to change some things which at the end of the day, you will have way more capex on the table. So economics are also to be there. One thing is clear, guys, we are cooking, and we are cooking the planet. That's what I know. That's the only thing I know. And tonight, we have to be very clear when we go back home. When we say to our kids, darling, I'm working for your future, or I'm screwing you because of money. I'm sorry, it's very rough, but this is exactly what I'm thinking and what I believe in. That's why Immersion for is a privately company is going to be resting, and we're here for lasting. We're not here for a sell. Just to say.
Okay. All right. So, and I don't disagree. And again, you're stealing from the next panel. All right. So let's talk about the other elephant in the room real quick. Two-phase got a bloody nose recently because of the liquid. And I don't know how many people are aware, but the liquid that two-phase is not very environmentally friendly.
Yes.
And there's been a lot of negative press and a lot of canceled contracts. Have we seen the end of two-phase, or are there options that are going to be made more environmentally friendly to take its place?
So yeah, my opinion on it, and you look at the different technologies out there, they're solving two different challenges. You have some that are helping with the rack level cooling, and some that are helping with the room level cooling, so getting the heat effectively out of the data center. And then you have some that are helping with your high heat chips. So where you need the two-phase fluids in a lot of cases to deal with these high heat chips, because they need a certain amount of heat taken away. They're getting really hot. So if you can't use the two-phase fluid, all of a sudden you still need another way to solve that. And then we have customers going to single-phase direct liquid to deal with those hot spots. Seems to work for quite a long way down the chip stack. Like we're talking over 1,000 watts and able to deal with it without even needing to think about some of those two-phase fluids. But I think, there's lots of vendors out there using two-phase fluids. I think that they're going to find ways to innovate, and it'll be up to the data centers and the market as to what they adopt in the end.
Okay.
Sorry again. I don't see any future for two-phase due to the nocivity of the liquid. And in fact, the reason why of the two-phase was as soon as the liquid was touching the hotspot, it was becoming gas in order to become liquid again and so on and so forth. The problem is just the way people understand, I would say, the way liquids circulate and understand also the viscosity of the liquid as well as the molecular, I would say, stability. We need to, for that, we need to use, I would say, the single-phase liquid, which doesn't expand and stay molecularly stable and become, I would say, less viscous when it's touching the hotspot. After that is all about liquid circulations, talking about the way the liquid circulate in order to avoid any hotspot whatsoever, and also the way the liquid also is running within the system. It is all about thermal conductivity. It is an industry which is well known for 100 years. We are not doing anything better than the people who are doing the heating system in any buildings that we know. So we should learn from what it is. And there is nothing wrong on using, I would say, the pumping as soon as you're not choosing pressure in order to push that liquid. You need to understand the liquid the way it is, the way it collects calories, and the way, I would say, it can basically avoid the hotspot no matter what. After that, it's a matter of adjusting the right temperature within the tub.
Okay, you and I are going to get a pint. We're going to have a thermodynamic debate about what you just said. But are there any questions?
Can I just make a comment? I think part of the challenge is that the consumers of IT are not requesting it, right? So the people that are putting the IT systems in, they're not obviously going to immersive cooling, direct-to-chip cooling, or whatever it might be. So last question, because we don't have much longer, is how can we encourage them to start, how can we deal with the supply chain side of it? Do you know what I mean? Because if everyone wanted it, then we'd be building it, wouldn't we?
Can I explain? We did one commercial test in the market a year ago. We actually said if you start using liquid cooling and we can recapture the heat in the data center, we can actually make money by selling the heat. And 10% of the money that we make by selling the heat, actually we give as a discount on your power bill back to the users. Well, conceptual, very, very nice, but it still didn't lead to any more business. So apparently the hurdle is pretty big. And I think that's what we as an industry do wrong, because we're preaching to ourselves here and we have an internal debate about DLC versus immersion and nobody cares. The real issue is actually how are we going to resell the heat and how can we become an heat producer?
But reselling is the problem. That's the big misnomer in the whole industry. If you give the heat away for free, the marginal,
Yeah, but if we forget about,
we do.
But if we forget about the heat for a minute, I think if you look at the chip manufacturers and the server manufacturers, they're starting to support immersive cooling. You know, Dell are starting to recommend it. You know, there's a good relationship that Dell have got with one of the vendors. Supermicro are starting to, you know, support it as well. It has taken longer. I mean, the data center industry, from a facilities perspective, been talking about it for a decade, right? And now you would think that the IT server manufacturers were more advanced because the cycle of change moves so rapidly than the facilities guys. This is the first time that the facilities guys have been ahead of the chip vendors. Do you know what I mean?
Yeah.
But now it's starting to become warranted. It's starting to become in standard SKUs. You can see that it's going to be moving, and it's going to be moving faster. The heat side of things and the financial incentives are different. It's about whether or not people are willing to immerse it.
It's price.
And there's another
Well,
political
and-
element as well. But
Right. Anyway, that was my closing thoughts.
Well done. All right, please thank my panelists.
Yeah. Thank you. Thank the panel.